In going over this problem on 2D kinematics, remember that you do not need to write down all the work. The problem and all of this video will be on my website. What you need to be writing down is your 4x6 card that's going to go onto your flip chart. So write down what's going to help you get 2D kinematics problems in general. And I'm going to try to say things as I go that will help you to figure out what you should put in there. So this first problem, 2D kinematics, uses the same kinematic equations that we did for the first one. We used them a lot, but make sure that all four of those are on that note card somewhere first off. And then write down a quick series of steps that will help you to do these. On this first one it says a monkey has a coconut on the top of a cliff of height h. If she drops the coconut, how long will it take to reach the ground? So I know that V1 equals 0 when you drop something. And so there's certain special things, like when you drop something, when it gets to the top of its arc, when it gets to the same height, make sure you write those things in on your card. I know that the distance it's going to fall is negative h. It goes negative because it starts up high and falls down. If I have my cliff, it starts below where it ends up. And then, can't see that. And then I know that the acceleration is negative g, and I'm trying to find time. I want to put all four variables over there on these so that I can quickly find which equation it is. I find the equation d equals v1t plus 1/2 at squared. And then I plug everything in that I know. This becomes negative h. This whole term becomes 0. This is negative g, and I'm looking for t squared. Cancel out my negatives because I multiply both sides by negative 1. I take the 2 and the g to the other side, so I get 2h divided by g equals t squared. And I end with t equals the square root of 2h over g. I did a really quick one with variables here. The rest of it's with numbers, but this variable, finding the time when the initial velocity is 0, appears on every AP test as a variable. So this is something that maybe you should put on your card as well, and be familiar with that. And this can be if it has an initial velocity just in the y direction of 0. If you have an initial velocity here, the x, all in the x, you'd still use this particular equation. On the second one, we give it an initial velocity that is 10 meters per second at an angle of 30 degrees above the horizontal. Whenever we have an initial velocity that's not in the x and y directions, we have to separate it into v1x and v1y. Using sines and cosines, it's always the hypotenuse times either the sine or the cosine. If it's the adjacent side, we know this has to be cosine of 30, and this has to be sine of 30. Oh, sorry, 10 sine 30. And so when we do that, 10 cosine 30 is 8.66. 10 sine 30 is 5. So then we set up an x column, and we set up a y column. And I like to leave space to do my work next to them. On the x side, I throw v1 equals 8.66. I know that v1 on the y side is 5. I know that the acceleration in the x side is always 0. That should be a note card. Acceleration on the y side is always negative 9.8, unless there's some added acceleration, and usually they don't do that to you. I know then also I'm going to the top of its flight this time, and remember the special situation for top of its flight means that it's y v2 equals 0. So then I know I'm trying to find how much time it takes to get there. So I'm looking for a kinematic in the y direction that has v1, v2, a, and t. So use a different kinematic. v2 equals v1 plus at. 0 equals 5 plus negative 9.8 times time. Or I could put 10 in there. This one 10 ends up being a lot easier, so I might do that. I take this 5 to the other side. It's negative 5. But since I have a negative there, I'm going to cancel both those out. So I say 5 equals, and I'll make that 10 because it's easier in this case. And so my time equals 0.5 seconds. I have the second one done. For part C, also going to 2D, I'm going to put my columns again. I have an X column, I have a Y column, leaving space again. I still have my V1 equals 8.66, my V1 equals 5. My acceleration here is 0. Acceleration here is, let's go with the 10 now, because since I said that, let's go with that, it's easier. Then I know that in the Y side, I have a displacement of negative 50. In the X side, I want to find my displacement. Because for this one, they're asking how far from the base of the cliff. That's dx. They're telling me that is 50 right there. So, I want to find that, but I don't have enough information there. I always go to the side where I have three things, I can always find a fourth. In this case, time is the one that'll transfer from one side to the other. So what I can do over here is say, I want an equation that has those four variables, so I use d equals v1t plus 1/2 at squared. And I, negative 50 equals 5t plus, and that's sometimes say that, call that 10, so half of that is 5t squared. That's a nice thing because I can divide it all by 5. Sorry, that's a negative 5 there. But other than that, I have to use a quad form, so it's not a great problem. But I'm going to divide by 5, so I get 10t plus negative t squared. And so then I say 0 equals negative t squared plus t plus 10. And there's a whole bunch of different ways of solving kinematics. But this one, you could put it into quad form if you remember that. But we could just solve this one by factoring, right? So we could say t, well, it turns out my factoring plan was a little overambitious. I thought it would just because my numbers ended up so nice, but I ended up having to put it in quad form. They won't necessarily, I've never seen them make you use quad form on the AP test. They work it so that you don't. But if you have to, you just do the opposite of b plus or minus the square root of b squared minus 4 ac all over 2a. And you can do that, and I think that you know that formula, and so you could do it, but we never had to. Anyway, we get the time is equal to 3.7 seconds, and that's the one thing that transfers back to the y side. That definitely needs to be on your note card. So I take my time, I put 3.70 on the x side. Now I have enough to solve for distance, and I do that by using the equation that has these in there. D equals v1t plus 1/2 at squared. My distance is what I'm solving for. 8.66 times the time, which is 3.70, and I get that my distance is 32.04 meters. That problem of finding how far from the base of the cliff is on a lot of AP tests, so make sure you understand that. It's not so bad, it's pretty easy, but you do need to know it. This last one is the most complicated of them, and remember on AP tests that's generally how it works. We get more complicated as we go. And this one, I'm going to have my cliff, I fly off of it, and I want to know the speed there at the bottom. And to do that, I'm going to make my two columns, x and y, put my numbers in. I know that my v1 in the x is 8.66. I know that my v1 in the y is 5. I know that a is always 0 on that side, a is always negative 10 on this side. And this time, I could put in the numbers that I'd found out, right? I could put in the distance that I solved for there, and I could put in the time, but I want the fewest things possible, so I'm only going to put in the ones that I know first. And this one over here, the thing that I know first is the distance is negative 50. I could put in the time, but I want to use the fewest calculated things possible. Since I'm trying to find out what the v at the end is, I'm going to have to find both the vy and the vx, and I'm going to have to add them as vectors. So that's the hard part. The nice thing is that on the x side, since the acceleration is 0, my velocity stays constant. You know, I could say that v2 equals v1 plus at. I'm looking for v2, and since that all goes to 0, v1 equals v2. So my v2 here is 8.66. Oops, that's not a 6. On the y side, I'm going to actually have to solve for v2, and that uses a different equation. My last equation is v2 squared equals v1 squared plus 2ad, and I know that v2 squared, which is what I'm looking for, is equal to 5 squared plus 2 times negative 10 times negative 50. And then I get v2 equals 32.02. Now I want to take those two things and add them together as vectors. So remember, I have to set up a triangle for this. I know this side of the triangle is 8.66. That side is 32.02, and I want this side, that's c, and then I also need the angle because it's a vector. So I do a squared plus b squared equals c squared. 8.66 squared plus 32.02 squared equals c squared. I get to my c is 33.17. And I say that the tangent of theta is 32.02 over 8.66, opposite over adjacent. And then to get theta by itself, remember I have to do this tangent -1 to this side, but I have to do it to both sides. So in my calculator, I type in tangent -1 of 32 over 8.66, and I get that the theta equals 75 degrees. So my final answer is 33.17 meters per second, 75 degrees below horizontal. Now, it turns out that this particular problem, when I'm trying to find the velocity down at the bottom, would have been easier with energies. I could set mgh plus 1f squared equals all of 1f squared at the bottom and get the answer a lot faster, but since I'm doing 2D kinematics, I'm going to show it to you this way. Alright, that's it.